Hello YouTube! In this video I'm going to show you how to find the exact value of one trig ratio when you know another trig ratio and you know the quadrant that the terminal side of that angle is in. But before I actually show you how to do this, there's a couple of things that we need to make sure that you know. So let's look at some of those first. The first thing that we have to know are the definitions of all 6 of the trig ratios. If you don't already know them, learn them. Pause the video, get something to write these down on. We'll be referring to this throughout the video. You'll also be referring to this as you work these types of problems. The second thing I want you to notice is that I've already drawn our triangle with the angle theta in it. Notice that it's on the coordinate plane. The leg that helps create theta is always on the x-axis. The hypotenuse of our triangle always starts at the origin. The opposite side from theta is always going to be parallel to the y-axis. Notice that I've already labeled my sides adjacent, opposite, hypotenuse. For those of you who have studied trig on the unit circle, I've also labeled these as X's and Y's and R's for your reference. The next thing that we need to be familiar with is not quite as important if you take the time to draw your diagram and put your angle theta in the correct quadrant, but we do need to be familiar with the signs that the different trig ratios have in different quadrants. Sine and cosecant are related to each other, and their signs are the same in the different quadrants. Cosine and secant are also related to each other, and their signs are the same in the different quadrants. Tangent and cotangent are also related to each other, and their signs in the different quadrants are the same. If you're not familiar with these, pause the video, copy these 3 diagrams down. In the first example, we're going to find the exact value for sine of theta if cosine of theta is -3/7 and the angle theta is between 90 degrees and 180 degrees. I want to start by drawing a diagram for the angle theta. If theta is between 90 and 180, the angle is in the second quadrant. So I draw a triangle with angle theta in the second quadrant. The next thing I need to do is insert numbers on the sides of my triangle. Refer back to the cheat sheet, and we know that cosine is adjacent over hypotenuse, or if you prefer, x over r. I know that the hypotenuse is never negative, so that means that the negative sign on that -3/7 must belong to the 3. The diagram also forces that issue as well, since 3 is an x value and it's on the left side of the y-axis, it must be negative. The problem asked me to find sine of theta, so I need to go back to my cheat sheet and find out what sine of theta is. The definition for sine is opposite over hypotenuse, so looking at my triangle, I need to know the value for this side here, because this is the opposite. Well, it's a right triangle, so I can use the Pythagorean theorem to find y. So y is the square root of 7 squared minus -3 squared. Go through to the arithmetic. We get the square root of 49 minus 9, which is the square root of 40. The square root of 40 will simplify as 2 times the square root of 10. So now I know that this opposite side that I need for sine is 2 times the square root of 10. Now that I have found the length of each of the sides of the triangle, I can refer back to my definition for sine and pull out the information that I need. Sine is opposite over hypotenuse, so sine in this problem is 2 times the square root of 10 over 7. For the second example, we're going to find the exact value for tangent of theta if cosecant of theta is the negative square root of 5 and the angle theta is between 3 pi over 2 radians and 2 pi radians. If you're not familiar with radians, 3 pi over 2 radians is 270 degrees, 2 pi radians is 360 degrees. Pause the video right now and see what you can do about coming up with a diagram, and if you really feel adventurous, go ahead and see if you can work it out all on your own, then check it against my work. Okay, the first thing I want to do is draw a diagram in the correct quadrant. I know that theta between 270 and 360 is in the fourth quadrant. So my picture with the diagram has theta in quadrant 4. I go back to my cheat sheet and I find out that cosecant is hypotenuse over opposite. One of those two numbers has to carry the negative. The hypotenuse is never negative, so the opposite, which is y, must be negative. That also agrees with my picture because that y value, that side, is below the x-axis, and y values that are below the x-axis are always negative. Now I'm going to go back to my cheat sheet and find the definition for tangent. Tangent is opposite over adjacent. So from theta, I have the opposite, -1, but I need the adjacent. The adjacent is the x value. It's also a leg. I can use the Pythagorean theorem to find this distance. So x is the square root of the square root of 5 squared minus -1 squared. Doing the arithmetic, this is the square root of 5 minus 1, which is the square root of 4, and the square root of 4 is 2. So this adjacent side, this x value, is positive 2. I know it's positive because it's on the right side of the y-axis, and x values on the right side of the y-axis are always positive. Now that I've gotten all three sides of my triangle, I can use my definition for tangent, opposite over adjacent, and I can pull out the needed information. So the side opposite theta is -1, the side adjacent to theta is positive 2, so tangent of theta must be -1/2. I hope this video has helped you in working with trig functions, especially being able to find the exact value of a trig function. Just remember the important things. You've got to know your definitions for the 6 trig ratios. You need to draw a picture of your triangle in the correct quadrant. Put your numbers in on the correct sides. Use the Pythagorean theorem to find your missing side, and then pull out the information that you need for the trig ratio that they asked you for. Keep at it. Eventually it will make sense to you.